Okay, so today we will discuss about materialized view. Okay. What is materialized view? Before that, basically, we already have discussed about the normal view, right? The normal view or regular view. Mm, so there is a so in Snowflake, actually there are two type of views are available. One is normal view or regular view. Another one is materialized view. Okay. Now, whenever we are talking about the normal view, what happens, like whenever we create a normal view in Snowflake, generally, not only in Snowflake, in other databases as well, what happens is basically it creates the view, but does not execute the underlying query at the time of creation, right? This is what happened. That's the reason whenever we call the normal view, every time it executes the underlying query and it gives you the record set fetching from the base table. What I want to mean, for an example, this is the normal view. Okay, this is a normal view. Create or replace view name as select star from, like that. Some basically query we have written here, and the base table of the view is orders table because we are fetching the data from the orders table. So base table of the view is orders table. On top of the orders table, we are actually doing some calculation, and then the record basically we that on top of that we created the view. Now whenever I will execute this statement, it will just create the view. Okay, it will not execute the underlying query. Whatever query we have written inside the view, that will not execute at the time of creation. On the other hand, whenever I will write like, okay, select star from view name, or if I use that view for any join purpose, any query purpose, so whenever that view would be called, so that can be directly called or by through any query or something. At that time, whenever the view will be called, at that time, this underlying query will be executed, and whatever record sets are there will be fetched by the query, that will be returned as a view record set. Okay, that is what actually happening in case of normal view. Normal view does not store any record. So the bottom of the line is normal view does not store any record. Normal view, every time we call the normal view, it will execute the underlying query and it will fetch the result set. That is what it will happen, but it will not basically execute, but it will not store any record. That is what the normal view does. Okay. On the other hand, if I talk about the materialized view does not work like a normal view. In case of normal view, whenever we create the view, it will not execute the underlying query. Whenever we call the view, at that time it will execute the underlying query. But in case of materialized view, at the time of creation itself, it will execute the underlying query, and that record set will be stored separately as a ready-made data in your storage. What does it mean? That means in case of normal view, every time you will call the normal view, every time the underlying query will be executed, whatever calculation, whatever thing you have mentioned in the query, what that derivation, whatever derivations you have mentioned in the query, every time that will happen on the base table and it will give you the record set. That is what happens in case of normal view. But in case of materialized view, whatever calculation, whatever derivation, whatever you are doing through the query, that will be happening only one time. So that calculation the derivation, everything will happen through only one time at the time of creation of the materialized view. Once it is derived the record or it fetch the record from the base table, it will store that record separately in your storage as a ready-made data, as a materialized view data. So basically, it will store the data as a materialized view data, and the data we call it as a pre-computed record set. Why? Because after that, whenever we will be calling the materialized view, like we will be writing select star from this materialized view, whenever I will write select star from materialized view, at that time it will not execute the query on the base table at that time, because this record set already stored as a materialized view record, and this record set already stored separately in your storage, and that table name will be mview underscore order. So whenever I will call like this way select star for materialized view, it will not fetch the record from the base table, because this query again will not execute, because this query already executed, and whatever record is returned by the query, that is stored separately in your storage as a mview underscore order. So whenever I will call this view, it will directly fetch the record from the mview underscore orders. It will not fetch from the base table. It will not do this calculation again. It will not do this group by again, because this ready-made record already stored as a materialized view name, and that's the reason this record again, whenever I'll call the view, it will not do the all the things again. It will not aggregating the things, it will not filter out the things, it will directly get the record from the view itself. And that is the reason materialized view improves the performance. Basically, materialized view always improves the performance. It increases some cost as well, basically, irrespective of the your normal view, but it will but it will not it will always improve the performance as well. Materialized view is the features, not only in the Snowflake, in other databases as well. It is the features to improve the performance, and basically, so by using this view, we can improve the performance as well, right? Uh, Remember one thing, because materialized view stores record, that's the reason we can create the cluster key also on the materialized view. So, like you can create the cluster key on the table, similar way you can create the cluster key on the materialized view as well. So that also is a plus point. So in case of normal view, because it does not store any record, so we cannot create any cluster on the normal view. Normal view does not store any record. Normal view or regular view, it's just a data representation. Whatever query you will be writing inside the view, so while calling the view, actually it will be executing the underlying query and it will throw you the record. That is what it will do. But in case of materialized view, the record set already stored as a separately as a materialized view name, and that's the reason whenever we fetch the record from the materialized view multiple times, the base table will not be accessed directly. The record will be fetched from the materialized view. I'll show you practically how basically these are all the differs. Before that, we have to understand a couple of more things. One thing is basically normal view and materialized view is having little difference. Like normal view can be created, or basically not normal view or regular view. Normal view can be created on top of a query which is having multiple tables joining with each other. For an example, you have multiple tables there in the in the query, and joining with each other. You have used some basically join conditions and all. So in those cases, normal view is fine. Normal view can be created on top of the query, which is having multiple table and join conditions. But materialized view cannot be created on top of multiple tables. So that what does it mean? Whatever query you will be writing inside the materialized view definition, that query should contain only one table. In case of normal view, whatever query you are writing as the definition of the view, you can include there multiple tables joining with each other. In case of materialized view, only one table will be there in the query. You cannot have even self join. So no join conditions will be allowed in case of materialized view. Okay. So this is the major difference between these two. And along with that, there are a couple of more differences are there. I have written those part in the basically in this PPT, so you guys can read it from there. Mm, you can see can query only on a single table. Okay, joins including self joins are not supported. Materialized view cannot query materialized view or non-materialized view. So any view you cannot include in the query which you will writing as a definition of the materialized view. Many aggregated functions are not allowed. Mostly analytical functions like Windows functions are not allowed. Does not support having order by limit clause. Okay, so these are all some a couple of limitations are there in case of materialized view. Okay. Question is that in which cases we will be using the materialized view. Materialized view. Okay, another thing you have to understand here. Let me tell you. Then we will discuss that thing. Okay. So there is the materialized view refresh concept is also there. What is materialized view refresh? For an example, as I told you, materialized view stores record. For an example, let's say at 8 o'clock, I had a sales table and there I had 100 records. Okay. Now at the same time at 8 o'clock only, let's say at 8 o'clock only, okay, I'm not writing the time at 8 o'clock only. I created a materialized view, let's say MW underscore sales. I created, this is the materialized view. Okay, materialized view I created here. And this materialized view, whenever I created the materialized view, I written the query like select star from cells. Okay, I created the materialized view on top of the table. Or let's give a where condition also. Let's say where city is equal to, let's say, Delhi, like that. Okay. I have written a query on top of the materialized view. Okay, so this is the materialized view query. Okay, now sales table is total having 100 records. For an example, let's say I'm assuming in this sales table, daily record is let's say 40 records are from Delhi city. So if there is a couple of cities are there from Delhi, there are 40 records in the sales table. So that means, so what does it mean? It means if I write here select star from MW underscore cells. If I write here MW underscore cells, how many record you will be getting? 40 records, right? So this is the scenario. Hope you understand. So initially we had the at 8 o'clock we have the sales table. There 100 record was there in the sales table, and in the sales table there are different countries was there. Now so Delhi, basically the different cities was there. Now for an example like Delhi, there was a city called Delhi, and after that in that city there was a 40 record belongings to Delhi. Okay. Now whenever I am creating the materialized view, I have written select star from cells where city is equal to Delhi. So that means this query will be returning these 40 records. So as I told you, materialized view will be storing the records. So that's the reason this materialized view contains the 40 records, right? This materialized view contains the 40 records. So whenever I'm fetching the view from data from the materialized view, I'm getting 40 records, right? That's what I'm doing here. Okay. Now let's say after some time at 9 o'clock, what you did, you inserted in the sales table. In the sales table, you inserted, let's say, 50 more records. Right now, in the total record of the sales table is 150 record. But for an example, let's say daily record becomes earlier it was 40. Now let's say 5 more record added to the daily. So total 45 records are there. Daily record is 45 records. Because I added 50 more records into the sales table, maybe in between these 50 records, 5 records belonging from daily. So that's the reason earlier daily was 40 records. Now total 45 records daily got. Okay. So in this situation at 9 o'clock, if I write select star from cells where city is equal to Delhi, how many record I supposed to receive? 45 records, because I'm running it on the base table, right? Now, if I write here select star from basically MW underscore sales. Now here, what is basically our thought process says? Our thought process says, because this view created at 8 o'clock, because this view created at 8 o'clock, and that's the reason this view stores 40 records from there. Okay, this view, that means this mview underscore cell, this view created at 8 o'clock, their total 100 record was there in the sales table. In between that 100 record, daily was the 40 record was belonging from the daily. So that's the reason if you are fetching the record from the sales table, mview underscore sales table, then only 40 record was returning. Okay, only 40 record was returning. That means from the view also you will be getting 40 records at the time of 8 o'clock. But 9 o'clock, your view supposed to have that 40 records only. In the other database, if you write this query, you will be getting 40 records only, because the view has not refreshed. This is here is the refreshment concept comes. Because if we make any changes in the table, the same thing should be applied on the view also. Otherwise, because till now the view is having 40 records only. At 9 o'clock, we added 50 records on the sales table, so daily record became 45. But the view contains 40 records only, because the view is not refreshed yet. Now at 9 o'clock, whenever the sales table got updated with some data, so the view also should be refreshed. Refresh means the underlying query will be executed again and the record will be updated. And because the new record set, the underlying query will be executed again, and whatever the record set comes from the base table, that will store as a materialized view record. And that's the reason, the view refreshment is needed. This is the case where refreshment concept comes. This is not the problem with the normal view, because normal view does not store any record. Whenever I will call the normal view, every time it will execute the underlying query and it will give you the record set. If I call the normal view at 8 o'clock, it will give you 40 records. If I call you the normal view at 9 o'clock, it will give you 45 records. Why? Because this normal view always executes based on the base table, not on the view. But materialized view will not execute the base table again and again. Materialized view only execute the base table at the time of creation. So here you created the view at 8 o'clock. So at that time, the daily record was 40 records. So the materialized view stores the 40 records only. Now, if you insert anything or update anything or delete anything in the base table, the underlying record, if any underlying record has been updated or modified on the base table, so basically according to that, your view also should be updated. Okay, then only we will be able to say like view and table is in sync. So that is what we call it as a refreshment of process. So basically the view refreshment is needed here. In the other databases, we actually do it manually. Now in Snowflake, we will be doing it automatically. And always remember, in case of other database, you will be able to see the old record only. But in Snowflake, you will be always be able to see the new record. That means though the view is not refreshed, but still it will show you the latest record only. I will show you practically everything, so you will be able to understand. So basically, though the view is not refreshed yet, but still it will show you the latest record only. This is the main benefits of the Snowflake materialized view. Snowflake materialized view does not depends on the refreshment process, because here we don't refresh the view. The view will be refreshed by the system itself, by the Snowflake itself. It's a serverless features like your other serverless features called cluster key, Snowpipe. So like that way, materialized view also a serverless features. Okay, materialized view also a serverless features. You can see here. So we already have defined the serverless features earlier. So let me go there and check. You can see. So Snowpipe database replication we have seen. Okay. So automatic clustering also we have seen. Now materialized view maintenance. This is also a serverless features. This is also a serverless features. Okay. And that is the reason. So what happens here, whenever the view will be refreshed, so basically it will refresh the it will bring the view sync with the base table. Whatever the latest record are there in the base table, that will be updated in the view. That is what the refreshment process, but that will happen through the Snowflake's own job itself. So it's a serverless features, and whatever credits will be consumed, because it has to execute your basically underlying query again, and the latest record has to be stored as a materialized view. That's the reason it needs the computing power as well, because serverless features is nothing but like Snowflake will be using their own computing power or own processing power to do your stuff. So that's the reason. So whatever credits it will be consuming, that credits will be added to your account. Like same cases like Snowpipe, automated reclustering, data replication, whatever we have seen till now. So similarly, materialized view also will be refreshed, and by Snowflake serverless features, and it will be whatever credits will be consumed, that will be added to your account. Okay, so and you have to pay for it. So materialized view refreshment is not free; it is definitely chargeable, and that is the reason it is best suitable if you create a materialized view on top of your legacy data. Legacy data in the sense, like for an example, let's say you have some data available in your table, and that data is basically not much updated, deleted, inserted. Let's say you have couple of 10 records, sorry, 10 years back record in your table, and that record not much updated, deleted, modified, rather I can say. Those data is basically kind of legacy data. So on top of those data, if you create the materialized view, definitely it will improve the performance, as well as it will basically not incur much additional cost. Because if you frequently insert, update, delete on the base table, then according to that your materialized view also need to be refreshed again and again, and this refreshment needs the computing power, and it will be chargeable. So that's the reason. But it is not like you cannot create. No, we do create on the table which updates weekly, monthly, but at the same time, basically it is recommended like you create the materialized view on top of those table to save your cost actually, which does not have much insert, update, delete happening frequently. Okay, so that you can save the cost, right? So that is the theoretical part. So remaining you can read from the basically the PPT. Okay, and we will be going to the practical and see what happens here. So first of all, I will be creating the normal view. You can see this is the normal view creation. I will select the database first. Mm, Let's select a database, and there I will be creating this normal view. This is the normal view creation statement. So you can see at the time of creation of the normal view, we will not use the virtual warehouses. You can see your virtual warehouses is still in suspended mode. We will not use the virtual warehouses at the time of creation of the normal view. Okay. But again, at the time of creation of the materialized view, you can see your virtual warehouses will be utilized. You can see compare underscore WH is getting utilized, and if you come here, you will be seeing it is started. So why it is happening so? Because whenever we created the normal view, it did not executed the underlying query. But whenever we created the materialized view, at the time of creation itself, it is executing the underlying query. And that is the reason it needs the virtual warehouses to be utilized. Okay. Now, if I execute the data from the normal view, let's say I'm calling the normal view, definitely at that time it will be using your compute underscore WH, because at that time, basically, it will be executing this query and it will be returning you the record. That's the reason. Definitely, while using the calling the view, it will be using the computing power. At the same time, whenever you are fetching the data from the materialized view, it will be fetching the data from the view, not from the base table. That is the main thing you have to understand. For an example, let's say I'm going to the query history here. Now, fourth statement I executed. First, I created the normal view. This is the normal view. Then I created the materialized view. This is the materialized view. Then I fetch the record from the normal view and I fetch the record from the materialized view. So for all the statements we will be checking. So first you can see this is the normal view creation statement. So let's click on it. You can see if you come down, this is the normal view creation statement. The view got created here. Now if you come and check the query profile, you can come and check the query profile. And if you check the query profile, you can see only the view got created. Nothing else. Only one step is there, that is called the view got created. Even no execution, nothing happened here, right? This is the normal view creation. Now, if you check the materialized view creation statement, if you go here, now you can see if you come down here, so you can see this is the materialized view creation statement. Okay. Now, whenever materialized view created, if you go to the query profile, there are two steps are there. One step materialized view got created. In the second step, you can see the entire thing happened here. Okay, table scan happened, aggregate, whatever the count we use, that aggregation happened, that filter conditions happened, and finally the record has stored as a table. Okay, a new table called mview underscore orders. Okay, that is the reason we called materialized view as a basically materialized view stores record. Now, if you come here, now whenever I call the view, normal view, let's say I called here the normal view. So you can see this is the normal view creation statement, calling the normal view option. If you go here in the query profile, you can see at the time of calling of the normal view, this thing happened, which already happened in case of materialized view. Now you can see table scan happen, aggregation happen, results return, and from where the results is getting returned from the orders table, right? From the base table. If you check here, from where it is getting from the base table, right? At the same time, if you go to the materialized view, this is the materialized view statement, and if you go to the query profile, now you can see what will happen. Now, if you come here, you can see that aggregation is not happening, right? The aggregation is not happening. So, and the record from where the record is getting returned, the record is getting returned from the mview underscore orders, not from the base table. The aggregation is also not happening here. You can see the aggregation is also not happening here. And the record is directly, so the already aggregated record stored as a materialized view, from there it is fetching the record. That is what it is happening, right? This is the difference between the normal view execution and materialized view execution. You can see in case of normal view, the aggregation will happen at the time of calling the view. Okay, but in case of materialized view, the aggregation will happen earlier itself. While created the view, at that time the aggregation happened. This is the materialized view creation statement. At that time, this aggregation happened and all. Now going forward, it will not aggregate the record. It will fetch the record from the materialized view itself. That's the reason we call it as a basically pre-computed record set. Okay, or ready-made record. Clear? Now let's say, so this is the mainly difference between the normal view and materialized view. Okay, if you write the show views, if you execute the show views, then you will be getting both the view, like materialized view, normal view. Both the view will be returned by the query show views. Base table, everything will be there, and you can see, okay, text will be there. And remember, if you create the view with the secure keyword, like create or replace secure view, if you write, so in that case, the secure materialized view, in case of secured materialized view, basically, if you create the materialized view with the secure option, the text will be hidden from the other user. This thing we already discussed in class of row level security. So basically, both the view is working with the same way. Basically, this scenario will be same for both of the view. Like if you created the view with the secure keyword, then the text, the underlying definition will be hidden from the other roles, not the owner of the view. Only owner will be able to see the definition of the view. Other roles, other people who got the select access, they will not be able to access the definition of the view if it is created as a secure. So here it is secure option is there. Both of the secure option is false means simply they are not secure. That is non-secured view. And is materialized option is true means that is materialized view. It is false means that is normal view. Okay, that is one way to fetch the details of the normal view, materialized view. Now if you want to fetch only the materialized view, you can write show materialized view. Show materialized view will give you only materialized view details, not the normal view. This is the materialized view, and you can see this many records are available in the view. You can see cluster by column is also there, like you can create the cluster key on the view. These many records are available in the view. This much storage has been occupied by the view. Okay, and this is the base table name orders. And there is a column called invalid column, invalid reason, behind by column. These are all the things are available. We'll understand about this three column now. For an example, let's say to understand the three column, what I will do, I will create first I will create a table called orders table. Okay, I will not take much record. I will take only a couple of record. Let's say I'm taking 100 records, and what I'm doing, I'm creating first the orders table. Okay, so let's create the orders table first. With 100 records, I created the table. Okay, and once the table got created, I will be basically creating one materialized view on top of that orders table. You can see I created the orders table here. Now I am creating a materialized view which is based on the orders table. So create or replace materialized view name as select star from orders, where order O underscore order priority is equal to one urgent. Okay, so this is what I will be writing. Okay, so that means the create or replace materialized view name as select star from orders, where O order priority is equal to one urgent. Now you can see this query is returning how many records? 22 records. So whenever I will create the materialized view also will contain the 22 records. So let's create the materialized view here. Created the materialized view. Now what I can do, if I can check the details of the show materialized view. Now you can see this is the materialized view I created. If you come here, 22 records are available. This much of storage has been occupied, and right now if you check the invalid column is the false and no invalid reason is there. If any data, if any alteration if you do on the base table, let's say you drop any column or maybe you modified the data type of any column. For an example, let's say let's come here, nested JSON public tables. This is the orders table. We have, these are all the columns we got here. Okay. Now, for an example, let's say I want to change, let's say I modify this columns data type. So what I will do, I will write here alter table orders, modify. I don't know whether I'm correct or not. Modify, 1 second. I don't know about the syntax. I'm not confirmed about the syntax. Okay, let me try Parquet. Let's say here I made it 5. So that means what I did, I modified this one. Let me refresh. You can see now it became varchar 5. It was varchar 1. Now it became varchar 5. So I just increased the size of the character. Okay. Now, if I go and check the show materialized view, you can come here and you can check here what is the your invalid command. Now invalid command is true. So that means if any changes you make on the base table, that means let's say your base table got dropped, any column from the base table you dropped, any data type of your base tables column you modify, okay, or maybe any extra column you added in the base table, in any cases, like if any alteration you make on the base table, I'm not talking about the DML statement. If you do any DML statement, that is not making your view invalid. But if you execute any DDL statement on top of the base table, then automatically you can see your base table will be, your materialized view will be invalid. DDL statement was executed on the base table orders, marked materialized view as an invalid. So your materialized view will be invalid if you make any DDL statement on the base table. So any DDL statement like your drop, alter, this statement, if you execute, your materialized view, which is created on the orders table, will be basically invalid. Now, if you fetch the data from the materialized view, you will be getting this invalid message. So let's say I'm writing here select star from, you can see the failure during expansion of the view, materialized view, this is invalid. Invalid reason is DDL statement was executed on the base table orders, mark materialized view as an invalid. So that you have to be very careful. Like once you created the materialized view, then after that, if you modify the base table, in the sense, I'm not talking about data level. Insert, update, delete, anytime you can execute. That will not invalid your materialized view. But any DDL statement, if you execute on the base table, then according to that, you have to create your materialized view also again. Otherwise, the view will be invalid. Okay, that we have to understand. Second thing, let's say I will be creating one more table. Create or replace table new underscore orders as the same way I'm getting the record from the orders table, and there also I will take only 100 records. Okay, and let me create the new orders table. So I'm creating a new orders table here. So this is the new orders table created, and also I will be creating one materialized view which is based on the new orders table. Okay, So mview top new orders as select star from new orders from the order priority is equal to 1 urgent. If I execute this query, it is returning 20 records here. You can see it is returning 20 records. So that means the view will also be containing 20 records only. So let's execute. Now this is the materialized view created. Now I will write show materialized views like. Now you can see this is the materialized view. Now if you go on the right side, you can see 20 records is stored by the view. This much of storage has been occupied. Right now the views is invalid is false. That means the view is valid, and also the behind by column is 0 second. Remember one thing, if the behind by column is 0 second, if the behind by column is 0 second, that means your view and the base table is in sync. That means your view and the base table is in sync. That means whatever data is there in the base table, the same data available in the materialized view also. That means there is no changes happened after creation of the view on the base table. Okay, so once the view is created, after that we didn't make any data changes on the base table. So that means if there is no changes on the base table, then that is the behind by column is 0 second. If you see any value here, you have to understand the base table gets modified. For an example, let's say this is the new orders, this is the view I created. Now let me copy this statement and come down. And here I will write this one. So let me write here like select start from. So if I execute the select start from materialized view, 20 records will be returned. Okay. Why 20 records is returning? Because the underlying query, this was the underlying query of the view. The underlying query was also returning 20 records. That's the reason the materialized view is also returning 20 records. And if you see the show materialized view, I will write here like so that you can understand properly. So you can see in this view is also containing 20 records. This is the view that is also containing 20 records. Okay, fine. Now let's say I insert 100 more records into the base table. The base table is the new orders table. This materialized view has been created on top of this query. So that means this materialized view's base table is the new orders table. Now new orders table right now, how many records are there? If I check entire new orders table, total 100 records are there. And whenever I applied this condition on top of that 100 records, we got 20 records. And that 20 records is actually stored as a materialized view. Now let's say in the new orders table, I inserted 100 more records. So let's execute. If I insert 100 more records on the base table, this is the base table for this materialized view. Now on the base table, I inserted 100 more records. Now if I fetch the record from the new orders table, how many records it will return? Earlier it was 100 record. Now it again 100 record increase. So now total 200 record is there. Now once the 200 record is there, that means if you execute this query, it should be returning more record. Earlier 20 records was showing. Now it is showing 42 records. So 22 records increased. Earlier it was showing 20 records. Now it is showing 42 records. Right? Now if I execute this show materialized view like this one, how many records it will be showing here? You can see still it is showing 20 records. So that means in the view it is showing 20 records. In the view level it is showing 20 records only, because the view is not yet refreshed. How will you understand the view is not refreshed? The behind by column is updated with some arbitrary numbers. If the behind by column of the view is not 0, we have to understand the view is not refreshed yet, or view is not synced with the base table. So in that case, this query is returning you 42 records. So this view also should be containing 42 records. And whenever this refreshment will happen, this behind by column again will be updated with 0. Because as I told you, this refreshment will done by the Snowflake serverless features. That's the reason till the time the refresh is not happened, if I fetch the data from the view, it will be showing you 42 records only. This is what the difference of the Snowflake materialized view always shows the latest record. Though the materialized view is not refreshed, if you go to this show materialized view statement, still you will be able to see 20 records only, not 42. But whenever you are fetching the data from the materialized view, you are able to see 42 records, because Snowflake committed to show you always the latest record. Okay. Now you don't need to bother about the refreshment and all. It will take some time, but as of now, like, you can check, like, after some time, whenever you will be practicing this scenario at your home, after a couple of minutes, like 15 minutes, 20 minutes, if you check again this function, like information schema dot materialized view refresh history, there is a function called materialized view refresh history. By using this function, if you check here, you will be able to see some record, like when the refreshment has been started, when the refreshment has been end, how much credits has been utilized, and what is the name of the materialized view. So you will be able to find out those information from here. Okay, and that is how the materialized view works. So you can see still now the materialized view is not yet refreshed. Probably you can see 20 records, but whenever you are fetching the record from the base table, from the materialized view, you are getting 42 records. Okay, so that is the main difference of the materialized view in case of traditional normal views. Clear? Any doubt, any question? Okay, all good? Fine. So that's all. We'll join again on the next week, and probably the next week will be the our session will be completed. We have couple of more classes pending. So if I summarize that, so I will be having one class on the external table. Then we will be having the procedure class. Procedure class will be taking 2 days. Along with UDFS, I'll cover UDFS also there. And after that, we'll have one Azure class. So total 4 classes needed. So after that, if anything needed, that will increase. Otherwise, next week the session will be over. Okay. Fine. Thank you.
The meeting has ended. Thank you for joining. Goodbye.